Okay, let's see the 10th question. 9th question is over. How much ml of hydrogen gas is liberated? That is 5.6 ml. Now the 10th question, the quantity of electricity is reducing. The electricity is reduced 12.3 grams of nitrobenzene. 12.3 grams of nitrobenzene. How much quantity of electricity is required? But the passing of electricity is only just 50% efficiency is only present. Then it becomes 100% means 100% we want means we might have to multiply it with 2. Okay, let's see. First we'll write that chemical reaction. The 10th one, nitrobenzene. Nitrobenzene, already we know that benzene ring having NO2 group. This nitrobenzene, we are doing what we are doing? Reduction we are doing. Then converted into aniline. Is converted into aniline, and the remaining hydrogens, 2 hydrogens converted into 2 moles of water. Now it utilizes how many hydrogen atoms? In the presence of HCl and iron, it utilizes 6 moles of H plus ions. 6 moles of H plus ions means 6 faradays of electricity is required. So for reduction, it requires 6 moles of electrons. 6 moles of electrons is nothing but it is 1 mole. 1 mole of nitrobenzene converted into 1 mole of aniline completely. It requires 6 moles of electrons is nothing but 6 faradays. But weight of, what is the gram molecular weight of nitrobenzene? Gram molecular weight of nitrobenzene. Is equals to, the gram molecular weight of nitrobenzene is equals to 123 grams. But how many, how much grams of nitrobenzene they gave? Only the number of moles of nitrobenzene is equals to weight is equals to 12.3 grams by its gram molecular weight is equals to 123, just is equal to 0.1 mole. Okay, 1 mole of nitrobenzene requires 6 faradays. Okay, if it is 0.1 mole requires 0.6 faradays. And then if 100% efficiency, its efficiency is, it is just 50% efficient. Then 100% efficient is equals to, therefore 100% efficiency is equals to 2 into 0.6 faradays is nothing but 2 into 0.6 into 1 faraday is nothing but how many coulombs? 96,500 coulombs. Okay, then the current, required current for the reduction of 12.3 grams of nitrobenzene into aniline when it having 50% current efficiency, then the required current is equals to 1,15,800 coulombs. 800 coulombs. So the answer is first option. First option is correct. When the current efficiency is 50% means the resultant value we have to multiply it with 100, then it becomes 100%. Okay. Now, so here the main important thing is how that nitrobenzene is converted into aniline. It utilizes 1 mole of nitrobenzene is converted into 1 mole of aniline. Utilizes how many moles of electrons? 6 moles of electrons is nothing but 6 faradays electricity is required. Okay. So after basing that, we are calculated because 1 mole of nitrobenzene is not present, just 12.3 grams. 12.3 grams is nothing but 0.1 moles. But 0.1 mole of nitrobenzene converted into aniline with 100% efficiency is equal to 1,15,800 coulombs electricity is required. Okay, students. Let's see the next 11th question. 11th question, 9.65 amperes current is passed for 1 hour through a Daniell cell. The loss of mass of zinc at anode. At anode, what happens, ma'am? Oxidation will take place. At anode, oxidation will take place. The zinc solid is converted into Zn2 plus loss of 2 electrons. Okay, loss of 2 electrons. Now, how much weight of zinc losing when that 9.65 amperes current is passing for 1 hour in a Daniell cell? The weight loss of zinc in Daniell cell is equals to W is equals to E into I into T in seconds. Okay, by 96,500. 96,500. Okay, that E means equivalent weight of Zn plus 2 is equals to gram molecular weight by N factor is nothing but 65.4. The gram molecular weight, gram atomic weight of zinc is 65.4 by 2. Okay, and I is equals to 9.65 amperes. T is equals to 1 hour time is nothing but 16 to 60 seconds. Then the weight of zinc loss at anode is equals to E 6.65.4 by 2 into I 9.65 into 60 into 60 divided by 96,500. Okay, this is on simplification. We will get approximately 11.77 grams. 11.77 grams means first option is correct. Okay, students. So here indirectly we are using Faraday's first law. The Faraday's first law is equals to E into I into T by 96,500. E equivalent weight of zinc. What is the oxidation state of zinc is in +2 state. That's why its N factor is 2. The gram atomic weight of zinc is 65 or 65.4 by 2. Then equivalent weight came and I value gave and T must should be in seconds. Then we'll get weight. This is on by simplification. This we'll get 11.77 grams. So the first option is correct. Okay, let's see the 12th question. 12th question. The electrochemical equivalents of two substances E1 and E2. Okay, the current that flows to deposit their equal amounts at cathode, they must should be in the ratio. What is the ratio? Because according to Faraday's second law, the weight deposited, the weight is equals to E into I into T by 96,500 is nothing but I into T is nothing but Q. E into Q. E into Q. Then 96,500. Okay. So the electrochemical equivalent C1 and E2 they gave the current that flows to deposit the equal amount at cathode. Equal amount at cathode in the same time period. It must should be in the ratio. Means the Q ratio we need to find out. Then the W is constant. Here the weight is constant. Then E1 into Q1 is equals to E2 into Q2. Okay. So the ratio of the current deposition of equal amounts means the Q1 by Q2 is equals to E2 by E1. Then the Q1 is to Q2 is equals to E2 is to E1. Okay, so the answer is E2 is to E1. Second option is correct. Okay, students, here just the weight, for example, the equivalent weights they gave E1 and E2 for a substance. Now the amount deposited at respective electrodes is same, but how much quantity of electricity is required? Then the formula W is equals to E into Q by 96,500. Okay, so in this case, the W is constant means E into Q is equals to constant. EQ is equals to constant. Equivalent weight and the quantity of electricity is equals to constant. Then the ratio of Q1 and Q2 is should be in the ratio of their equivalent weights, because the Q1 is inversely proportional to E equivalent weight. Then Q1 is to Q2 is equal to E2 is to E1. So the answer is second option. Okay, let's go for next 13th question. The 13th question, how long will current of 1 ampere? How long will a current of 1 ampere means time we have to calculate for 1 ampere current is passing for the complete decomposition of copper from 1 liter, 1 normal copper sulfate solution is present. In 1 liter, 1 normal copper sulfate solution is present. Then normality is equals to molarity into n factor. Okay, in this case, molarity is equals to normality by n factor. Then normality, how much is present? 1 by n factor for copper sulfate is 2. For copper sulfate is converted into copper plus 2 plus SO4 2 minus. That's its n factor is equals to 2. Then molarity is equals to 1 by 2 is equals to 0.5 molar. Now in 1 liter solution, molarity is nothing but N by V, V in liters. Then number of moles, if V is equals to 1 liter, then N is equals to 0.5 moles. Now we'll get idea, means 0.5 moles of copper is present, 0.5 moles of copper is present. 0.5 moles of copper means the weight of copper is equals to 0.5 by number of moles by gram molecular, gram atomic weight of copper is 64, is nothing but sorry, the weight of copper is equals to N into gram atomic weight. N is 0.5 into 64 is equal to 32 grams. Okay, for deposition of 32 grams of copper at respective electrodes, when the current is passing 1 ampere, then how much time it will take? See, that weight is equals to equivalent weight of copper plus 2 into I into T by 96,500. That weight is equals to 32 is equals to equivalent weight of copper is equal to copper equivalent weight is equals to 64 by 2 is equals to 32, means 32 into I value 1 ampere and time by 96,500. Okay, this 1 and 1 will cancel, then T is equals to 96,500 seconds. See, when the 1 ampere current is continuously passing through 96,500 seconds, then then 32 grams of copper will be deposited. 32 grams of copper will be deposited. Okay, students. See here the weight of copper. Indirectly we are calculated. Normality they gave. That normality we are converted into molarity. Then the molarity we are converted into number of moles. The number of moles we are converted into weight. Okay. For 32 grams of copper for deposition, how much time is required when that I current is equal to 1 ampere. We are passing continuously. The time is equal to 96,500 coulombs. Okay, understood? So this kind of questions also very, very important. Let's go for next question. 14th question. 1 Faraday of electricity is passing through 1 liter 1 molar solution. 1 liter 1 molar solution. 1 liter 1 molar solution means number of moles is equal to 1 mole. Is it or not? Whatever it may be, solute is present, the number of moles of solute is equal to 1 mole. But 1 Faraday we are passing, then that number of moles of silver from silver nitrate, tin from tin chloride, copper from copper sulfate will be deposited. Then the number of moles, if 1 Faraday current is passing, then the number of moles of silver through a solution 1 liter 1 molar aqueous silver nitrate, tin tetrachloride and copper sulfate, the number of moles of Ag, tin and copper will be deposited at respective cathode. The number of moles the number of moles of metal deposited at respective cathode is equals to number of moles of solute by number of moles, nothing but number of Faradays. Number of Faradays into number of moles by n factor. Okay. See here, number of Faradays is equal to 1 and the number of moles of solute present in the solution is equal to 1 and by n factor is nothing but 1 by n factor. Okay, so the number of moles of silver is number of moles of Sn is number of moles of copper is equals to 1 by 1 plus 1 by 1 is 1 by tin. What is the n factor of tin? Plus 4. Here tin silver is plus 1, the tin oxidation state is plus 4 and the copper oxidation state is plus 2. Then 1 by copper n factor is 2. What is the ratio? 1 is to 0.25 is to 0.5. Then the answer is 1 is to 0.25 is to 0.5. The first option is correct. See, in this case, first the given electrolytes, how many moles of metal ions are present, first we have to calculate. 1 molar 1 liter solution means all silver is 1 mole is present, and tin is also 1 mole is present, copper is also 1 mole is present, and we are passing 1 Faraday current. Then how many number of moles of metal deposited respect to electrodes is equal to number of Faradays into number of moles of electrolyte by n factor. By n factor. Here 1 Faraday and 1 mole is present, 1 by n factor. So the silver, the number of moles of silver is to number of moles of tin is number of moles of copper is equal to 1 is to 0.25 is to 0.5. So if they are asked weight means we know the number of moles, then the moles converted into weight means the weight ratio is equal to number of moles into its gram atomic weight. It's a gram atomic weight. See, 1 mole of silver is depositing means weight. What is that? How much weight? The weight ratios of silver is to weight ratio of tin. Weight ratio of copper. Do you want to calculate? Means the number of moles into its gram atomic weight we need to do. Means silver 108, tin 108 into 0.25 into its gram atomic weight, copper 0.5 into its gram atomic weight. Then the weight will comes, and as well as weight ratios also will comes. Okay, let's go for next question. Okay, 15th question. Let's see. 0.05 molar aqueous NaCl solution is electrolyzed. Okay, 0.05 molar NaCl solution is electrolyzed. If that current strength is 0.5 amperes and 193 seconds there passed, finally the concentration of Na plus ions. The concentration of Na plus ions. Okay, while NaCl, aqueous NaCl, on electrolysis, we are producing Na plus plus Cl minus. Water is present means it can be ionized to gives H plus and OH minus ions will forms. At anode, chlorine gas will be liberate. Okay, and at cathode, hydrogen gas will be liberates. Hydrogen gas will be liberated. So you do not produce the electrolysis of NaCl does not form does not produce or does not form Na plus Na sodium metal Na at cathode. Hence Na plus ions concentration Na plus ions concentration does not change. Okay, so 0.05 molar NaCl is present. Means what is the concentration of Na plus ions? 1 mole of Na plus means 1 mole. 0.5 molar Na plus ions are present and 0.05 molar Cl minus ions are present. So the final solution concentration is 0. Therefore, Na plus ions concentration is equals to 0.05 molar only. It does not changes. So the answer is first one. Because Na plus ions cannot be reduced at cathode, and cannot be converted into sodium metal, because the deposition order of H plus ions is more when compared to Na plus. That's why the H plus ions can be easily reduced to convert into H2 gas. That's why Na plus ions are not electrolyzed. Then Na plus ions concentration is not changed. So it is initially how much it is present, finally is also same. Then the Na plus ions concentration is equal to 0.05 molar only. Okay, let's go for 16th question. 16. Which of the following could not be liberated from the suitable electrolyte by the passing 0.25 Faradays of electricity is passing? 0.25 Faradays electricity they are passing. Then whether through any electrolyte, silver, for example, silver metal is present, then it produces 0.25 molar, 0.25 Faradays electricity we are passing, then how many moles of silver will forms? Then the number of moles, let's see the first statement is correct. Which one is wrong statement they're asked? So the first one is F is equals to 0.25 Faradays. Then the number of moles, moles of silver deposited is equals to number of Faradays. Faradays by n factor is nothing but silver ions n factor is 1, then 0.25 by 1 is equals to 0.25 moles. See here 0.25 Faradays electricity passing, then produce 0.25 moles of silver. This is correct statement only. Now let's see that second statement. Copper. Now number of moles of copper is equals to 0.25 by n factor is 2. 0.25 by n factor is 2. That many moles present. Then the weight of copper. Weight of copper is equals to number of moles into 0.25 by 2 into 64 is nothing but how many? 8 grams. But in the question how much weight of copper they will be deposit, they gave to 1 to 32 times 0.25 is nothing but 1 by 4, 32 by 4 is nothing but 8 grams. So, but instead of this 8 grams, 16 grams they gave. So that's why the second statement is wrong statement, is not matching. It does not liberate when 0.25 Faradays of electricity is passing through the copper electrolyte, copper sulfate electrolyte. It produces only 8 grams only, but not 16 grams. But not 16 grams. Okay, the second statement is wrong. Now let's see the third. Why the third is correct or not, we'll check. But however, we got answer, but still we'll check that third and fourth options also. 2 grams of O2. 2 grams of O2 is liberates or not, we'll check. Let's see. O2. Number of moles of O2 is equals to O2 means oxygen atom. 2 oxygen atoms means each oxygen atom n factor is 2. Then O2 n factor is equal to 4. Means 0.25 by 4. Then the weight of O2 is equals to 0.25 by 4 into 32. So 8 times 0.25 is nothing but 1 by 4. 8 into 1 by 4 is nothing but 2 grams. So the third statement is correct. 2.85 liters of H2 will be liberated or not, we will check. In that case, the fourth one, number of moles of H2 is equals to 0.25 Faradays by n factor of H2 is H2, n factor of H2, hydrogen 1, H2 means 2. Okay, then the volume of H2 is equals to 0.25 by 2 into 22.4 is nothing but 11 by 4 is nothing but 2.8 liters. So the fourth statement is also correct. Now the wrong statement is second one. So the answer is second. Okay, here just I already earlier only this formula we used. Number of moles of substance deposited at respective electrodes is equal to given number of Faradays into number of moles of that electrolyte. Here 1 mole only they gave. That's why number of Faradays by n factor. Then number of moles of substance deposited will comes. That we can convert into weight, we can convert into volume also. So based on that, second statement is wrong. Okay. Let's go for next question, 17th one. 17th question. What is the time required for the decomposition of all silver present in 125 ml 1 molar when the current is passing 241.25 amperes? Time they asked first before find out the time how much amount of silver is present in 125 ml we will discuss. The 1 molar silver nitrate. 1 molar silver nitrate in 125 ml. Okay, 125 ml they gave. In that molarity is equals to number of moles by volume in liters. Okay, is nothing but molarity is nothing but weight by gram molecular weight into 1000 by V in ml. See here silver weight we need to find out. 1 molar silver nitrate is nothing but 1 molar Ag plus ions are present. Silver ions are present. Okay, so in 125 ml. Then 1 is equals to weight by gram molecular weight of silver is 108 into 1000 by 125. Then the weight of silver present in 1 molar 125 ml is equals to 13.5 grams. See, this 13.5 grams of silver is present. For complete deposition of silver metal, it requires how much time? When that current they gave, the time we need to find out. The W is equals to E into I into T by 96,500. Then the weight is equals to 13.5. The equivalent weight of silver Ag plus is equals to 108 by 1 is equals to 108. Then 108 into current. How many amperes they gave? 241.25 amperes into T by 96,500. Then the T is equals to 13.5 into 96,500 divided by 108 into 241.25. This is on simplification. We'll get 50 seconds. We'll get 50 seconds. So the answer is second option. Okay. See here indirectly the weight of silver. How much weight of silver is present or how much weight of silver is deposited? That not gave. But the solution concentration and volume they gave. So from that we are find out weight. For deposition of that weight when the current is passing 241.25 amperes and required time we are calculated. How much time is required? Simply just 50 seconds is enough. If 50 seconds that 241.25 amperes current we are passing through 1 molar silver nitrate solution, its volume is 125 ml, then immediately 13.25 grams of silver will be deposited respective cathode. Okay students. Okay, let's go for next question. 18th question. Mn3O4 is converted into 3MnO4 means here 3 moles are present means automatically 3 moles of MnO4 2 minus will forms. See here 3Mn oxidation state is +8. Here 3Mn, here each manganese oxidation state is +6. Here 3 into 6 is equal to 18 units. So change in the oxidation state. Oxidation number is equal to 18 minus 8 is equals to 10. Means for 1 mole, it is 1 mole, and it is also forming how many moles? 3 moles are formed. Complete 1 mole. So for conversion of 1 mole, Mn3O4 into MnO4 2 minus requires 10 moles of electrons, is nothing but 10 Faraday's current. 10 Faraday's current is required. So the answer is third option. Okay, let's go for 19th question. 19th question, let's see. The density of copper is 8 gram per ml. D is equals to 8 gram per ml. So here the thickness, area and thickness on both sides of the thickness is 10 to the power of minus 2. They gave the total volume, both side volume of copper, both side volume of copper is equals to 2 into area, 10 into 10 into thickness is 10 to the power of minus 2. Area into thickness. Okay, then it will cancel, is nothing but 2 centimeter cube is nothing but 2 ml. So 1 ml of copper has 8 grams. In the 2 ml of copper has 16 grams are present. Now in the question, the 16 grams of copper is present. By using copper sulfate solution electrolyzed is how much current is required. The density of copper they gave, the number of coulombs required. Number of coulombs required, Q value they are asked. So for this case, the number of coulombs is equal to copper plus 2, n factor is equals to 2. Copper plus 2 is n factor is equal to 2. Then